Welcome to the AP Physics video lecture. This is covering the law of motion, pulleys part 1. So what is a pulley? A pulley will change the direction of a force, and it looks something like this. Right. There you go. Okay. If a force is here, goes down, force of gravity is equal to mg, and let's say this is going to be negative, we see that the force going in the opposite direction, which goes up, is going to be positive. But do you see how it wraps around? So let's say it wraps around, goes back down. So here it's going to be positive force here. So that is going to be the direction. So a lot of people will see it rotates counterclock, which goes like this as positive, or you can say the other way, clockwise, would be negative. Okay, it's up to you how you want to do it. Some things that you need to understand is that the pulleys are massless and frictionless, so you don't have to include that mass here. It's not a new compound, right? It's not an other mass that you have to add. Okay, it's frictionless. Also, the strings, technically they're also massless. So yes, they're physical objects. Yes, they do have mass in real life. So in the system, we would have to include the mass of the string and the pulley. But for the math to make more sense in this class, we just ignore them. All right. So let's take a look at this example. Okay. So here we see that block 1 is 5 kilograms. So this is 5 kilograms. And this is 10 kilograms. If you let this go, you're going to see how it's going to fall. The reason why I made this positive right here is because it's going to fall. This is the way it's going to fall. This is going to be negative is because this is going to go up, because it's going to fall here. So that's how I distinguish it. And remember, if this is positive, if I'm going to take the falling to be positive, anything above it becomes negative. So the fall down is positive. So the force of gravity on mass 2 is positive. So the tension force going up is negative T. Comes down, it follows the pulley. So the down force of gravity on M1 is going to be negative. Likewise, if you go up on M1, the tension force here is going to be positive. All right. So just imagine you're wrapping yourself around here. Right. So here, the only two forces here, the force tensions here are the same in magnitude. So these cancel out, these cancels out. The only forces that you have here is the force of the system equals to Fg2, which is positive. And you're going to subtract, or you're going to add this force. So you can think about it like this if you want. Add the second force, G1, which is the same thing as just subtracting. All right. Then the force of the system breaks down into M1 plus M2 times, again, this is A cis in reality. Fg2 breaks down to M2G. Fg1 breaks down to M1G. Okay, that's how each part individually is broken down. Now we can solve for the acceleration. The top is the M2 minus M1G, because we factored out the G, which is like terms, divided by the mass on bottom of the system. So the way I think about this is that this on the bottom represents the mass of the system, and the top is going to be the force of the system. This makes sense because remember, A is equal to the summation of F over M. But now I'm just thinking about it in terms of systems, right? So system. Good. Plug in the values, you should get the value of 3.27. This section is also connected to your kinematics. You have an acceleration, but now they say determine the speed of the block of m1 at the time t equals 2 seconds. It's nearly what? Here they're asking for the v. The v is your question mark. What has time and velocity? Well, it should remind you of your kinematics equation. Okay, kinematics. So let's work through our kinematics equation. We write by labeling all the variables. So a was 3.27 meters per second squared. I forgot to put the units. T equals to 2 seconds, and v equals to 0 meters per second because the object is from rest. The only kinematics equation that has what we want with v question mark and having a, t, and v naught is our classic linear kinematics equation. V equals to at plus v naught. Plug in the values, you should get v equals to 654 meters per second. This makes sense because the object is accelerating at 2 meters, at accelerating 2.7 meters for every 1 second. Good. So now let's do a practice problem. This comes out from the AP Physics. Here it says an Atwood machine is set up by suspending 2 blocks connected by a string of negligible mass over a pulley, as shown above here. The blocks are initially held at rest and then released at t naught equals to at time t naught equals to 0 seconds. The speed of the 3 kilogram block at t equals to 2 seconds is mostly what? So this question is really asking for v question mark. But in the end, we have to solve for the acceleration first, right? So like before, we assessed the issue and we saw that the force of the system is equal to mass times mass of the system times the acceleration of the system. And it does that because the object is moving. There's going to be a movement here, right? I'm going to take this down here to be positive because it's going to fall. In our diagram, we saw that this is going to be our positive F G, and this is going to be our minus FG. So this is FG on 3, this is FG on 2. I just added the subscripts here for each mass. Then there is still the force of tension. There's a tension force up here, and there is a tension force up here. So this is negative and this is positive. These two are same in magnitude, so they both cancel out, so we don't need them, but they do exist. The question I have you here is this: how should I draw those vectors? Should they be the same length, or one should be bigger than the other? Well, the object is going to be falling, so this vector has to be longer. Then this has to be a little bit shorter, okay, to show that the force of gravity on the 3 kilogram object is pulling it down. So that is the diagram. Setting it up, summation of the force of the system equals to force of gravity of block 3, force of gravity on block 3 minus the force of gravity on block 2. Substitute that in, plug in the values. So mass this was m3 plus m2. FG3 was just m3g, right? Mass times acceleration, mass times gravity for the third one, and this one is just mass times gravity for the second one. Substitute that in, we should see that equation before. You should get 2 meters per second squared. Now it's like your kinematics equation. Plug in the values. T was 2. It starts v naught was 0 because it starts from rest. You get v equals to 4 seconds. Good. Now we do this problem, but now with friction. Okay, so an Atwood machine is set up by suspending 2 blocks connected by a string of negligible mass over a pulley, and shown in the figure above. The pulley has negligible mass, but there is friction as it rotates. This happens in real life. The system is released from rest, and after 1.0 seconds, the speed of the 3 kilogram block is 1.8 meters per second. Which of the following is the best estimation for the external force acting on the two block system? Well, we saw from before, if we did the normal calculation, that the acceleration when there is no friction is 2 meters per second squared. We got this from the previous problem. But the question is this. Now it says the new acceleration is actually 1.8. That is when there is friction. So, what is the acceleration of the friction? Well, it would be their difference. Okay? It would be their difference. So, a lot of students think like this and they subtract it. That's how they get 0.2. This is the acceleration due to friction. So we just plug it in. F is equal to ma. All right, the acceleration is 0.2 due to friction, times it by the mass, which is just 5, because this is mass of the system, of course, and you should get 1 Newton. That is the 1 Newton force caused due to friction. Due to friction. So in reality, when you do this in real life, your acceleration is going to be, your real life acceleration is always going to be less than your theory calculation, because there's friction involved. So example 2. Now we introduce a third mass, and that mass is a 3 kilogram. The third mass here is 10 kilograms. Okay, this was 5 kilograms. And the second mass here is still 10 kilograms. All right. So we're going to solve it. But to do this, without deriving the equation again, we can just modify one of our old equations. So you should have this to understand of the simple Atwood machine, right? So on top, we saw that the M2 minus M1G is just the force of gravity on the system. That's the only force that's acting vertically here. And divided by the mass of the system. So on top was the weight or the force of gravity of 2 minus the force of gravity or the weight on M1. Divide that by the system's mass, which is that. Now, when you introduce a third mass, what happens? Well, it should look something like this. On top, you're adding, so this is represented by this. So this can be seen as one block here. You can see this as the M1 block plus the M2 block. Okay, this is why you're going to see this as minus parentheses M1 plus M3. That's how you can see it. Okay, but they just distributed the negative in between. So the mass of the system is still the same way. So the only difference is that there is a new force of gravity due to the third mass, and here we add it to the first mass because this is on the same. This is because they're on the same hanging side, which is on the left side. All right. So we saw from our previous problem, we still treated this as the positive, okay? As the like our previous problem from before, we still treat this as positive, all right? So we saw that this was the equation that we got, and we know that again from the top, it was this, okay? Now we can plug it in. The mass of the system is M1 plus M2 plus M3, right? So the 10 plus 15 comes from the 10 right here plus the 15 here. These add up. So this becomes 15. The 15 here is represented by this 15. And this is still the 10 here, kilograms. So 10 subtract 15. This should get you the value of negative 5. Right, so this should be negative 5 times 10 is equal divided by 25. So this becomes negative 50 divided by 25. This is going to be equal to negative 2 meters per second squared. This is negative is because now it's going to be falling. This was your negative side, right? It's negative because it's falling on the negative side. Again, the negative just shows the direction component to it. All right. So let me clean it up and write that for you. So there's the math. And I said that the negative shows that the machine will rotate counterclockwise and the left mass will be dropped. Here's some argumentation for you to understand this a little bit much better. So Annabella says that there's a linear relationship between the net force and the acceleration of a system for a pulley system. As the net force of a system increase, the acceleration of the system will increase. Therefore, she argues that if she adds more mass to the pulley system, the net force will increase and the acceleration of the system will increase. All right? So, argue for or against this. You need a claim, evidence, and reason. Your claim should just be answering the question. Your math is your evidence, and your reason are your words. Try it. So, the first answer is actually she's incorrect. Why? Because we can show the acceleration equation, and we saw that if you add the third mass here, it's like the previous problem. Okay, force of gravity. Okay, this is when this is added to the left side. Okay, they add together. So now it's going to fall here. It's going to fall on the negative side. So will the acceleration increase? No, the acceleration will actually be negative in this case. There's no magnitude here. So if the mass is added to the left side, we saw that the weight of the mass 1 plus the weight of mass 2 will be larger. Sorry, the weight of mass 1 and the weight of the mass 3 together will be larger than the weight of mass 2. Therefore, the force of gravity of the system will fall down to the left side. They're showing it's going to fall in the negative direction. So here it's wrong because acceleration here would have been negative when she added the mass. However, you can actually argue the other way. You can actually argue she's actually correct. And the way you could have argued that is because now, look at it. This is when she added the third mass, but this is added to the right side. And this is the right side that she's referring to. When you add that to the right side and work out the math, it should look like this. So this is this part, M2 plus M3. We treated that as a mass. And you saw that if the mass is added to the right side, the weight of mass 2 plus the weight of mass 3 would be larger in magnitude than the weight of mass 2, than the weight of mass 1. Therefore, the force of gravity of the system will be positive and increasing. So it would be here, and it would be increasing, and it would be positive. Good job. Last thing is you might see a tension problem. And again, if you want to do this, same process. So let me show you here. So the first one, you can do the tension of this force. Okay. And again, summation of the force equals to tension minus FG1. Notice, because this is moving up. And if you solve for it, this should look like, because this is move up, right? This is like the elevator problem. As you move up, you're going to feel heavier. Why are you going to feel heavier? Because it's A plus G. Okay? So that is this is the A cis plus the normal G, the normal gravity. That's why it's 65.3 newtons. For this one, this is moving down, right? Move down, right? The T here is moving down for the mass 2. Right? No, let me change this in color so you can see this better. Let me make this green. So we saw that this is move down. So this is the moving down. So on the elevator problem, if you move down, you're going to feel lighter, right? Because this is going to be subtracting. So this is the A cis, and this is G. And it's going to be subtracting because that's your apparent weight. So the tension force here is still going to be the same of 65.3. Notice, either way, you still get the same value, right? It's just one is adding if you're going to go up, and one is subtracting if you're going to go down, right? But there you go. Those are everything that you need to know about pulley part 1.